Hi, my name is Gabi, and the goal of my PhD research is to improve radiation therapy treatments for cancer by using light. Radiation therapy is one of the most effective cancer treatments we have in our arsenal. It's estimated to benefit 50% of all cancer patients. And there are many different types of radiation therapy, but one thing holds common among all of them. Cancer patients would all seriously benefit from having more effective, targeted radiation therapy treatments in combination with surgery to improve cancer outcomes. Now, let's take a look at this brain, for example. To the naked eye, we see no difference between healthy and cancerous tissues. It all just looks like a brain. However, what if we could visualize cancerous tissue by simply shining light on it? Well, that's already a reality, and it's used in a technique known as fluorescence-guided surgery. In this technique, doctors feed a patient a drug that's preferentially taken up by cancer cells, and that drug is then converted into a luminescent molecule, and doctors literally just cut out whatever is glowing. However, this can be a problem because there's always some cancerous tissue that's left behind, and that can cause the cancer to regrow. What if we could modify this technique to not only show us where the cancer is, but to treat what remains? Well, we hope to do that using light-emitting nanoparticles. Think of a single hair on your head, which has an average thickness of 100,000 nanometers. A nanoparticle is only 100 nanometers, or 1,000 times smaller than the width of your hair. These particles are composed of elements that emit light when we hit them with X-rays, the same kind that are used in radiation therapy treatments. Our goal is to use these nanoparticles in combination with cancer-killing molecules that can be activated with light. By applying these nanoparticles to the region of the tumor where some cells still remain after resection, we can use radiation therapy in combination with the nanoparticles to kill cancer cells left behind after surgery, resulting in a more efficient cancer treatment. By using multiple approaches to kill cancer cells simultaneously, it makes it a lot harder for those cancer cells to stay alive. Think about it like a war maneuver, where an army attacks from both the air and the ground. It's really hard to keep up with both. But before we can do that, as chemists, we first need to synthesize a huge variety of nanoparticles and study their luminescence properties. First, to make sure that they're emitting enough light, but also to make sure that it's light of the correct wavelength used for treatments. Then we need to study them in cells where we can get a very good idea of how these nanoparticles kill cancer before putting them into actual people. This all sounds like science fiction, but we're inching ever closer to treatments like this each and every day, and hopefully we'll be able to help improve cancer outcomes for patients worldwide.